The question of whether all Jews are genetically related is a fascinating and complex topic that brings together elements of history, religion, culture, and science. Understanding the genetics of Jewish populations requires delving into their historical origins, the patterns of migration and dispersal over millennia, and the role of religious conversion, cultural practices, and intermarriage in shaping their diverse genetic makeup. It is important to note from the outset that Jews are not a monolithic group. Jewish identity is multifaceted, combining religious, cultural, and sometimes ethnic components. The genetic diversity within Jewish communities across the world mirrors the vast historical and geographic experiences they have undergone. The origins of the Jewish people can be traced back to the ancient Israelites of the Levant, particularly the land of Canaan, which encompasses modern-day Israel, Palestine, and surrounding regions. According to biblical accounts, the patriarch Abraham is regarded as the common ancestor of the Jewish people. The Jewish population is traditionally understood to have originated from 12 tribes descending from Abraham's grandson, Jacob, whose descendants became the Israelites. Over time, several historical events, including the Babylonian exile, 6th century BCE, the Roman conquest and destruction of the Second Temple, 70 CE, and the subsequent expulsion from Judea in the 2nd century CE, resulted in the dispersion of Jews into various parts of the world. This dispersion or diaspora led Jewish communities to settle in different regions, from Europe, Ashkenazi Jews, North Africa, Sephardi Jews, the Middle East, Mizrahi Jews, and beyond. This long history of diaspora and resettlement has had profound consequences on the genetic structure of Jewish populations. Some Jewish groups remained relatively isolated, while others experienced extensive interaction with local populations, leading to varying degrees of genetic mixing. As a result, Jewish populations today are not homogeneous but exhibit significant genetic diversity. In recent decades, genetic research has offered new insights into the degree of relatedness among Jewish populations. These studies have generally focused on the genetic markers found in the DNA of various Jewish groups and have compared them to both each other and to non-Jewish populations from the regions in which they have historically resided. One of the primary genetic markers used to trace Jewish ancestry is mitochondrial DNA, mtDNA, which is inherited exclusively from the mother, and Y chromosome DNA, passed from father to son. These markers provide insights into maternal and paternal lineages, respectively. Studies of these genetic markers have demonstrated that many Jewish populations share common ancestry that can be traced back to the Levant, the historical homeland of the ancient Israelites. Research published in 2010, led by geneticists from New York University and the Hebrew University of Jerusalem, found that different Jewish populations, despite their geographic dispersion, retain a core genetic signature that links them back to the Middle East. The study examined the genomes of various Jewish groups, including Ashkenazi Jews, Sephardi Jews, and Mizrahi Jews, and compared them to non-Jewish populations from the same regions. The findings revealed that while Jews from different parts of the world share common genetic roots, they also carry genetic signatures that reflect their historical interactions with local non-Jewish populations. For instance, Ashkenazi Jews, who primarily trace their ancestry to Eastern and Central Europe, were found to have genetic markers indicating both Middle Eastern and European ancestry. This is consistent with historical records suggesting that while the Ashkenazi Jews have Levantine origins, they also experience significant admixture with European populations over centuries. In contrast, Sephardi Jews, who primarily trace their ancestry to the Iberian Peninsula and North Africa, and Mizrahi Jews, who trace their lineage to the Middle East, show a closer genetic affinity to Middle Eastern populations, reflecting a lesser degree of European admixture. While the core genetic similarity among Jews supports the idea of a shared ancestry dating back to the ancient Israelites, the genetic differences that have emerged due to geographic dispersion and intermarriage highlight the complex history of Jewish populations. One of the most studied Jewish populations in genetic research is the Ashkenazi Jews. Genetic studies have shown that Ashkenazi Jews are relatively genetically homogeneous compared to other Jewish groups. This has been attributed to what geneticists call a bottleneck event. A genetic bottleneck occurs when a population size is drastically reduced, resulting in the loss of genetic diversity. In the case of Ashkenazi Jews, it is believed that a small number of ancestors gave rise to a much larger population over time. Historical evidence suggests that the Ashkenazi Jewish population was quite small during the early Middle Ages, but experienced rapid growth from the 10th century onward. The genetic bottleneck experienced by Ashkenazi Jews has left a significant imprint on their DNA, making them more prone to certain genetic diseases such as Tay-Sachs disease, Gaucher disease, and cystic fibrosis. These diseases are often described as founder effects, where a small initial population carries a higher frequency of particular genetic mutations that become amplified as the population expands. Despite their relative genetic homogeneity, Ashkenazi Jews still exhibit genetic diversity resulting from both their ancient Levantine roots and admixture with European populations. This admixture is detectable in their autosomal DNA, the non-sex chromosomes, which reveals the contributions of both Middle Eastern and European ancestry. In contrast to Ashkenazi Jews, Sephardi and Mizrahi Jews tend to have a stronger genetic connection to Middle Eastern populations. Sephardi Jews trace their origins to the Iberian Peninsula, from which they were expelled during the Spanish Inquisition of the late 15th century. Many Sephardi Jews subsequently settled in North Africa, the Ottoman Empire, and other parts of the Mediterranean. Genetic studies indicate that Sephardi Jews have a high degree of genetic continuity with other Jewish populations from the Middle East, reflecting their relatively closer geographic proximity to the Levant. Mizrahi Jews who trace their ancestry to Jewish communities in the Middle East and Central Asia show even greater genetic continuity with ancient populations from the Levant. For example, Jewish communities in Iraq, Iran, and Yemen have been found to have genetic markers closely resembling those of ancient Levantine populations. These groups, unlike Ashkenazi Jews, were less exposed to the genetic influences of European populations due to their historical isolation within the Islamic world. Jewish populations are not exclusively the descendants of the ancient Israelites. Over the centuries, there have been notable instances of conversion to Judaism, contributing to the genetic diversity within Jewish communities. One prominent example is the Khazars, a Turkic people who ruled a vast empire in Eastern Europe between the 7th and 10th centuries. It is believed that the Khazar elite converted to Judaism during this period, although the extent to which this influenced the genetic makeup of modern Jewish populations remains a topic of debate. Similarly, conversions to Judaism occurred in various other regions, including North Africa and the Mediterranean. These conversions, combined with intermarriage with local populations, introduced new genetic elements into Jewish communities, further diversifying their genetic makeup. It is important to recognize that Jewish identity has historically been shaped not only by ancestry, but also by religious adherence and cultural affiliation. This is particularly evident in the modern definition of Jewish identity, which includes people who convert to Judaism without any biological connection to the ancient Israelites. The relationship between Jewish identity and genetics is a complex one. On the one hand, genetic studies have confirmed that many Jewish populations share a common ancestry that can be traced back to the ancient Israelites of the Levant. On the other hand, Jewish identity is not solely defined by genetics. Judaism is a religion, and people have historically joined Jewish communities through conversion, as well as through birth. As a result, not all Jews are genetically related in the sense of being direct biological descendants of the same ancient population. However, genetic studies suggest that a significant portion of the global Jewish population shares common Levantine roots, particularly in their paternal lineages. At the same time, Jewish populations have also absorbed genetic contributions from the various regions in which they have lived over the centuries, resulting in a genetic mosaic that reflects both their shared history and their diverse experiences.